Hello everyone, myself Guru Joshi. Today we are going to study a topic from curve tracing. So it is tracing of parametric curves. The point to be taken into consideration while tracing a parametric curve x is equal to f1t and y is equal to f2t where t is a parameter. So firstly we'll study symmetry. The curve is symmetric about x-axis if x is an even function and y is an odd function of t. The curve is symmetric about y-axis if x is an odd function and y is an even function of t. Or the curve is symmetric about y-axis if after replacing t by pi minus t, x becomes negative and y remains positive. Okay, so for symmetric about y-axis we have two conditions, and if x and y both are odd function of t, then we can say that curve is symmetric about origin. Okay, now let's discuss the number 2, origin. Now the curve passes through the origin if both x and y become 0 for some real value of t. Okay, so if both x and y are becoming 0 for some value of t, then we can say that curve passes through origin. Now the third one is point of intersection. So point of intersection with x-axis. So what we have to do, find the value of t at which y is equal to 0. Okay, and then we'll find x for this value of t. Now to find the point of intersection with y-axis, we will find the value of t at which x is equal to 0. Okay, and then we'll find y for this value of t. Okay, now the number 4 is tangents. So tangent parallel to x-axis is obtained at a point where dy by dx is equal to 0, and the tangent parallel to y-axis is obtained at a point where dy by dx tends to infinite. Okay, now fifth one is maximum and minimum value. Okay, so we will determine the maximum and minimum values of x and y if it exists. Now the next one is the region. So we'll determine the region where x and y are real. Okay, the curve does not exist in the region where x or y are imaginary. Alright, now we will find the variation of x and y. So we will find the values of x and y for some values of t. Okay, now note, if x and y are periodic function of t having same period, then the curve is traced for one period only. Okay, now let's discuss one example. Trace the curve x is equal to a cos cube t and y is equal to b sin cube t. Now here x and y both are periodic function of t with period 2 pi. Okay, so we will trace the curve between 0 to 2 pi. Now first we'll discuss symmetry. Now the curve is symmetric about x-axis. Why? Because x is an even function and y is the odd function of t. Now we know that cos is even function. Okay, cos is even function and sine is odd function. Okay, therefore we can say that this x is an even function, okay, and y is the odd function. So the curve is symmetric about x-axis. Also the curve is symmetric about y-axis because after replacing t by pi minus t, okay, this x becomes negative and y remains positive. Now x is what? A cos cube t. Okay, so here just consider here cos of pi minus t. Okay, so this is the 4 quadrant. Okay, here we have 0, pi by 2, pi, 3 pi by 2, and okay, so pi minus means second quadrant, and in second quadrant cos is negative. Here we have cos cube, so we have 3 times minus, so this x will become negative, right? And if you will find sine of pi minus t, so again second quadrant sine is positive, right? So this y will remain positive. Okay, so we can say that the curve is symmetric about y-axis also. Now the second one is origin. Now the curve does not pass through origin because x and y both do not become 0 for any value of t. Okay, now the third point is point of intersection. Okay, so at t is equal to 0, if you will substitute t is equals to 0, okay, x will become, here cos 0 is 1, okay, so x will become a, and sin 0 is 0, so y will become 0. And at t is equal to pi by 2, okay, substitute pi by 2 over here, so x will become 0, and if you will substitute pi by 2 over here, y will become b. Okay, so the curve intersects the x-axis at a comma 0, okay, and y-axis at 0 comma b. So these are the intersection point. Now we'll discuss tangents. So firstly we'll find dx by dt and dy by dt. Okay, so x is equal to a cos cube t. Okay, so dx by dt is what? First bring this 3 over here, so it is 3a cos square t, and the derivative of cos is minus sin t, so this is the negative sign and sin t over here. Now we will differentiate y with respect to t. Okay, so you will get dy by dt as 3b sin square t into cos t. Okay, now we will find dy by dx. So dy by dx is dy by dt upon dx by dt. So dy by dt substitute over here, dx by dt, this will get cancelled, right? One cos will get cancelled, one sin will get cancelled. So what remains is minus b upon a tan t. Now, so at t is equal to 0, okay, t is equal to 0, dy by dx will become 0. Okay, so the tangent is x-axis at t is equal to 0, okay, that is at point a comma 0. Now at t is equal to pi by 2, dy by dx will tends to infinite, right? Now t is equal to pi by 2 means y-axis, so the tangent is y-axis at t is equal to pi by 2 means at a point 0 comma b. Okay, now we will find the maximum and minimum value. So maximum values of x and y are a and b respectively, because the maximum value of cos and sin is 1. Okay, so as we know the maximum value is 1, so x will be a and y will be b, and the minimum values of x and y are minus a and minus b, because the minimum value of cos and sin is minus 1. Okay, now we will discuss the region. Okay, now the maximum values of x and y are x is equal to a, y is equal to b, and the minimum values are x is equal to minus a and y is equal to minus b. Okay, so the curve will lie between minus a to a over here, okay, and minus b to b for y. Okay, so curve lies over here, that is from minus a to a and from minus b to b. Also we know that curve is symmetric about x-axis, okay, and it is symmetric about y-axis. Now we will write the variation of x and y. Okay, so here we'll take few angles, that is 0, pi by 6, pi by 4, pi by 3, pi by 2, and x and y over here. Okay, now if you will substitute 0, okay, so here cos 0 is 1, so you will get a answer. Substitute 0 over here, so sin 0 is 0, so y is 0. So we'll substitute pi by 6 over here. Okay, so substitute pi by 6 over here, take cube. So you will get this answer. Okay, similarly we have to write down all the answers for this angles. Alright, okay, so from this table at t is equal to 0, okay, point is what? A comma 0. So this is a comma 0. Now here we have taken angle in the first quadrant, that is pi by 6, then pi by 4, and then pi by 3, and then pi by 2. So at pi by 2, the intersection point is 0 comma b. Okay, so this is the intersection point p. So we will join this over here. So we are getting this line now. Okay, now we know that the curve is symmetric about x-axis, so we will get this portion. Okay, and also the curve is symmetric about y-axis, so we will get this side also. Right, so So in this way, we can trace the parametric curve. Okay. So I hope you have understood throughout the session. Thank you for watching.